All right, so in section 610, we're just going to be graphing. Everything's going to have to be like a graph, okay? So we're going to be graphing square roots. Like I said earlier, square roots only, no cubed roots, no fourth roots, nothing like that. So it's the most basic of the radicals. And let me just write down the standard form for us here, okay? So standard form of a radical. So the formula looks like this. Y equals A radical x minus c plus d. I know we're missing that b term that we always tend to have. Normally you have a, b, c, and a d, but in our case, it's just a, c, and d. Now, I don't know if you remember this from the other times that we did this. This is called our amplitude. All right, that's our amplitude. And I'm just going to put right here, if A is bigger than 1, then it's a thinner. No, I'm sorry. I'm thinking the wrong thing. It rises faster. Whoops. Sorry about that. Rises faster. If A is less than 1, well, I should put it probably within 0. Bless you. Between 0 and 1. So if A is a fraction, okay, it rises slower. So it rises slower. So it rises slow. So it doesn't kind of like jump up as fast. It kind of takes its time moving in an upward direction. So if A is greater than 1, it rises faster. If A is between 0 and 1, meaning it's some kind of fraction, it rises slower. Okay? The graph, by the way, is really easy. It's just kind of like a little arc. So it's not a hard graph to see. Now, part C. If C looks positive, then move left. C times. So remember how I always say that, like the C value is always telling you the opposite of what it really wants to do, right? So if it was like a positive 5, you should be going left, not right, okay, right? Because you think plus, that means go to the right side. No, it's really go to the left. If C was like a -2, if it looked like a -2, you really go to the right, okay? So that's what I'm writing right here. If C looks negative, then move right. C times. So C still has that same characteristic that it's always had, where it's telling you the opposite information. So a +2, go left. A +8, go left, right? If it's a -3, go right. -5, go right. Okay? So normally you'd want to go right if it was positive, but C is always telling you the wrong direction. And then the last part right here is D, and D is your vertical movement, okay? So if D is positive, notice not that it looks positive, but it actually is positive, move up D times. And if D is negative, move down D times. So if D is positive, go up. If D is negative, go down. This should kind of remind you of when we did like absolute value graphs and parabola graphs, right? Like all the formulas had that A, the C, and the D value. And they all meant the same thing, right? Move up and down, left and right. So it's still the same idea. Okay, so let me show you guys some of these graphs. We'll start off with the most basic of all the graphs because we want to see what it's supposed to look like normally. So for example number 1, we're going to graph y equal to square root of x. This is the basic parent function, as they call it, the most basic function. I'm just going to create a little grid here. You guys already have that on yours, so you don't have to worry about doing this. 1, 2, 3, 4. 1, 2, 3, 4. And from here, I'm only going to do the top on the right side, just to give you the scale idea. That way you know it's moving up by ones, to the right by ones. All right. Now, if you're going to graph this, notice, what is my A term here? What's my A value? The number in front of the radical. Not the index, the number in front. Is there a number in front of my radical? No. So what number is it then? Not a 0, because or else it would erase everything. A 1, right? So if it's a 1, there's no amplification of the graph. It doesn't go slowly. It doesn't go faster. It's just normal, okay? What's my C value? So that's inside of the square root, the thing that makes it shift left and right. Do I have one? No. So that's a 0. What's my D value? The thing that moves it up or down. Do I have one on the outside? No, I don't. So that's a 0. Okay. So now I just have to graph this function. So I'm going to create a table. Now, here's the thing you guys have to remember. Can I ever have a negative number inside of my x function? Or sorry, inside my square root? Like, can I do square root of -3? Unless you're going to do imaginary numbers, right? Which we did before, but you're not supposed to. So for my x values, I'm going to start with numbers that aren't negative. So let me start with 0. If I get a 0 and I plug it into square root of x, right? So y equal to, I'm going to put here square root of x. If I plug it into there, what's my answer? A 0. All right, so I'm going to put a point. 0, 0. All right. Now, when I pick points, I don't just want to randomly pick points because some numbers don't have square roots. So let me think, what other number besides 0 has a nice square root? And try to go like from small to big. The number 1, what else? 4, right? So let me try 1 and 4. After that, you could try 9, but we might already run out of space, but we'll see. If I plug in a 1, what do I get for y? A 1. All right, so 1, 1. If I plug in a 4, what do I get for y? A 2, bless you. So 4, 2. Bless you again. And there you go. So here is what my graph looks like normally. A little arc. Now the next number I would want to try is like a 9. Okay, I would want to try like a 9. Because the square root of 9 would be 3. But notice I'm out of space if I have to put a value at x equal to 9. Right? So that's why you don't want to like jump too far ahead. The reasons why I wouldn't pick like x equal to 2 is because I don't know, the square root of 2 is like 1.14 or 1.41 something. It's a little bit harder to graph. So I try to stick with numbers that give me good answers. Sometimes you can, and that's okay. Just use your calculator. But if you can, stick with the numbers for x that give you nice values when you do this work. So here's one example. This is from your homework. This is the parent function, very first problem you're going to do. And all graphs are supposed to mimic that. Sometimes they'll go a little they'll grow a little faster, okay? Or else sometimes they'll kind of go a little slower, all right? Sometimes they may shift, right? And do that. Or sometimes they'll be a little higher and do that. So that's what we're going to be kind of doing today, is graphing different looks, okay? So let me give you another one. So remember, this is like the basic graph right there, okay? So example number 2. So we'll graph y equals 2 square root of x minus 1. So slowly we're going to kind of move a little bit more difficult every time. I don't know about you guys, but it's nice to have the heater, but my body does not react well to the heater. Like, I dry up completely. Like, my nose dries up. I feel like my nose is stuffy. I walk outside, I feel good. Come back in, my nose is stuffy again. I don't have allergies or anything, not that I know of, but it's... Whereas my wife, she's totally fine with the heater. She wants it to be at 87 or something, like cooking. And I'm like, no, 70 is good enough. And my oldest daughter's like me, like we're over here suffering every time it's warm. So I don't know what it is, but it totally drives me up. Don't know why. So, all right. Here's another graph, okay? I'm going to identify some of the basic pieces. So what's my A value? 2. So since it's a 2, that means it's probably going to rise up a little faster, okay? What's my C value? It's not negative. That's my D value. D is negative 1 because it's on the outside. Is there a number next to the x on the inside? No, so this is a 0, right? So that means that this graph is not going to move left or right, but it is going to move which direction, up or down? Down, right? It's going to actually be one lower. So let me go ahead and set up a table here, x and y. 2 radical x minus 1. And then I'm going to pick numbers that, to me, would make sense. Okay? So I know I could try 0. If I plug in a 0, what do I get once I plug it into that equation? 2 square root of x minus 0. I'm going to get 2 square root of 0 minus 1. That's negative 1. So 0, negative 1. I'm going to put a dot right there. What other number should I put inside of the square root of x that has a nice square root? A 1. All right, we'll try a 1. So that's 2 square root of 1 minus 1. What's 2 square root of 1 minus 1? So 2 times square root of 1, that's 2. And then minus 1, that's 1. So 1, 1. All right, what number should I try next? A 4. 4 would work good because it'd be a square root of 4. So I'll try a 4 here. 2 square root of 4 minus 1. I know the square root of 4 is 2, and 2 times 2 is 4. 4 minus 1, 3. Right? So that's 4, 3. Now let me connect the dots. Remember, this is like a curve, so it is curving. So there you go. There's that graph. Notice it looks different than the other one, right? It's rising faster. It's going up faster. It's not as nicely kind of just going slowly. It's going up faster, okay? So that's what happens when you put an amplification in front of it that's bigger than 1. If it was smaller than 1 but bigger than 0, meaning a fraction like a half, a third instead of a 2, then it'd be crawling its way up just real slowly, okay? So are we okay with this one? Now, I've always been asked, well, Mr. B, if I know that, if I know the original function of x, okay, if I know this, I don't know if I'm actually able to grab it. Yeah. Can't I just like move it like down and to the left and just leave it like that? Like, can't I just do that? Just kind of move it myself? And I'm like, well, what about the amplitude? Because the amplitude is going to change the way it looks, right? So for this one, you do want to create a table so you can find the right points, because or else all your graphs are going to look the same, like this top one, okay? They're all going to look identical, even though their amplitude should be quicker or slower. You're going to keep drawing them all the same, and that's not actually correct. So use a little table to help you put the right points in the right place, okay? Let me give you another one like this. So we're going to kind of complicate it a little bit more. Let me see. I don't want to do that. Let's try this one here. So example number 3. And I'm going to zoom in a bit because I zoomed out. So example number 3, we're going to graph y equal 3 square root of x plus 1 minus 1. After this, I'm going to do one more and then we're done, okay? But I'm trying to show you like manipulations inside and outside of the function. So that way when you look at the homework, it all kind of looks familiar. All right, so let's draw a coordinate plane really quick. Just making my charts real quick here. Now this one I would say is like the trickiest one out of the ones we've done so far, because of the fact that inside the square root it's not just an x anymore. So you have to ask yourself, what numbers did I used to use with my xy chart? Well, I used to use a 0, a 1, and a 4, right? But if I put in, say, like a 4, what number is what's inside of the square root if I plug in a 4? Now it's a 5, and I don't know the square root of 5. So I got to think about that a little bit. Like, how do I make it a 4, right? But we'll get to that in a bit. So what's my A term? 3. What's my C term? A 1. What's my D term? All right, -1. So to me, that means that this graph is going to go once to the left, once down. That's going to be its starting point. One to the left, once down. But let's kind of make our table here. So that would be 3 square root of x plus 1 minus 1. All right. So what number should I start with? If I plug in a 0, what's inside of my square root? A 1. Now check this out. I'm going to actually put my 0 here, okay? I'm not going to put it at the very beginning because I actually would have started at a different number. So if I plug in a 0, 0 plus 1 is 1. The square root of 1 is 1. 1 times 3, 3. 3 minus 1, 2. So this 3 square root of 0 plus 1 minus 1 is 2. So 0, 2. Putting a dot right there. Okay, 0, 2. All right. I would have actually started at -1. Now you might say, well, wait. You said I shouldn't have negative numbers in the square root. Well, that's true. But if I plug in a -1, 3 square root of -1 plus 1 minus 1. What's -1 plus 1? 0. And what's the square root of 0? 0. So I haven't broken any rules. 0 times 3 is 0. And 0 minus 1 is -1. Now, why would I do that? So -1, 1. Okay? I'm sorry, -1, -1. I put +1. That's a mistake here. -1. Right there. So why would I do this thing, picking a negative 1? It's because remember what I told you? I wanted to have square root of 0, square root of 1, and square root of 4. If you look at my previous problems, that's what we had, right? Square root of 0, square root of 1, square root of 4. Those are nice square roots. So what I ask myself is, how do I get the square root of 0 if it's x plus 1? Well, x has to be negative 1. That's how I get a 0 there, right? The way I get a 0 is by using negative 1 and then adding 1 inside of this square root right here. Okay? How do I get a 1? Well, I'll use 0 because 0 plus 1 is 1, and that's what we did in the second one, right? So how do I get a 4? What number do I use? What plus 1 is 4? 3. So use a 3. Whoops. Let me put the 3 here. So look, 3 square root of 3 plus 1 minus 1 is. All right, square root of 3 plus 1. Well, that's the square root of 4. The square root of 4 is 2. Okay, 2 times 3, 6. 6 minus 1, 5. This is 3, 5. And now you just draw your line or your curve. Notice how much faster this one rose than the previous one. The other one was, the first one we did had an amplitude of 1. The second one we did had an amplitude of 2. This one has an amplitude of 3. And it's like almost looks like a straight line, right? Starting to get there. Are we okay with that? So the trick sometimes is picking the right numbers. You can pick any number you want. Let me make sure I state that. You can pick whatever number you like. If you always want to use 0, 1, and 2 forever, go ahead. But you may have to use your calculator to calculate some of the square roots because they're not going to come out to really nice numbers. So you might have to get like a bunch of decimals and stuff. I'm trying to avoid decimals. That way, when I graph, it's nice and clean, right? But you can use any number you want. You're not going to be wrong. Actually, that is incorrect. If you pick a number that doesn't work, your calculator will spit out an error, so you'll know, oh, I can't use that one. Okay, because you're going to try like square root of negative 3. It's either going to say error, or it might say like, wait, this is square root of 3i. You're going to be like, why I, right? I means it's an imaginary number. So for things like this, I always ask myself, okay, I want a 0, a 1, and a 4 in my square roots. What numbers do I pick so that I can get a 0, a 1, and a 4 to come out in that square root of x plus 1? So I kind of think about it. I'm like, okay, negative 1 gives me a 0 gives me a 1, a 3 gives me a 4. So I'll use those. So we're going to do one more like this, a little bit more on this trying to figure things out in your head. So this one I'm going to need a big graph because I think we're shifting 6 units. So let me do a big graph for us here. So last example. Example number 4. Well, you know what? Maybe I won't do the big shift. There's another one here that has a shift as well. No, but I do like the fact that this one has a fractional amplitude. So you know what? We'll stick with this one. So this has something that I didn't talk to you guys about in the very beginning. Okay, but let me go ahead and just draw everything and then we'll discuss it. So I'm going to put up my graph here. I got to go like 6 units. So you guys can draw however you'd like. I'm going to just kind of make it pretty large. Okay. That'll work. So let me see. Hopefully that's close enough. So 1, 2, 3, 4, 5, 6. Yeah, that's good enough. You can go by 2s if you want, bless you. I'm just going by 1s. Because sometimes when you go by 2s, your graphs get a little like distorted. So since I'm just trying to show it to you guys, I'll try to keep it as close to what it is as possible. So I did a 6 by 6, okay? What's my A term? It's a negative half, okay? That's my amplitude, negative half, which means it's going to rise slower, but think back to when we've graphed. When the amplitude became negative, what happened to the graph? So if I graph x squared and it looks like this, what did negative x squared look like? It opens the other way, right? It gets flipped. It gets flipped. So for us, this graph is supposed to look like this. That's if A is positive. If A is negative, using what we've known about other graphs, this graph's probably going to go that way, okay? So just remember that. Your A being negative is going to flip it, okay? It's going to flip it. So don't be surprised when you start drawing, you're like, don't be like, uh-oh, I messed up. This is going upside down. Well, yeah, because it's supposed to be upside down, okay? The amplitude is negative. What's my C value here? 6. So which way is it supposed to shift, right or left? To my left, right? It has to go left 6 units. So I'm expecting it to be somewhere like over here, okay? And what's my D value? 0, which means it's not moving up or down. It's staying steady on the x-axis, okay? It's going to be upside down and 6 units to the left. So let's make a XY chart here. The negative half square root of x plus 6. All right, so let's play this game where we try to figure out what makes it. Remember, square root of 0 is my goal for the first one. What x value would make the square root say 0 inside? X plus what is 0? Say again? Negative 6. Because negative 6 plus 6 is 0, right? So this will be 1 negative half, square root of negative 6 plus 6. Well, negative 6 plus 6 is 0. Square root of 0 is 0. 0 times negative half is 0, so it's 0. So I'm going to put a point at negative 6, 0. There we go. Negative 6, 0. All right. Now I need a point, or an x value, that will give me a square root of 1. Which one? I think you said it. Go ahead. Oh, negative 5. I thought I heard it this direction. So over there. It's like a ventriloquist or something. I thought Sonny said it. So I was looking right at you. So a negative 5. Plug in a negative 5 because negative 5 plus 6 is a positive 1. Right? So negative half square root of negative 5 plus 6. Well, negative 5 plus 6 is 1. Square root of 1 is 1. 1 times negative half, negative half. So at negative 5, it's negative half. Notice it's not jumping, right? It's jumping in small intervals. All right, now I need a 4. A negative 2 plus 6 would be 4, right? So good, negative 2. So negative half square root of negative 2 plus 6. So negative 2 plus 6 is 4. Square root of 4 is 2. 2 times a negative half is... Oh, wait a minute. I just realized. Well, let's calculate this, and then I'm going to fix something. I don't know if somebody else saw it. What's my answer for the bottom at negative 2? It's equal to... Remember, negative 2 plus 6 is 4. The square root of 4, 2. What's 2 times negative half? What's half of 2? 1. And make it negative? Negative 1. So, negative 2, negative 1. Where did I mess up? The point at the half, right? I graphed it at positive half. What is it supposed to be? Negative half. I accidentally graphed it on top. It's supposed to be down here. All right, and now just connect your dots. So here you go. Look at how flat that one looks compared to the one we literally just drew, right? That looks like it's shooting off the page immediately. This one's taking its time. Okay? So fractions tend to make the radical grow slowly. Whole numbers tend to make it shoot up like really fast. Okay? Depending on the number. Like a 2 is not terrible. 3s, 4s, 5s, like that thing's just flying. So that's basically all there is to today's work, guys. It's just you graphing these things and trying to figure out, like, is it going to be normal looking, upside down? Is it going to be stretching up like fast, like rising quickly? Is it going to rise slowly? How is it going to work? Okay. Now, if I could give you one really quick hint. So I didn't tell you this in the beginning because I wanted you guys to work this out in your heads. But here's a little hint. So CD is your starting point. This is where the graph starts. Okay, CD is where your graph is starting. Now, I put C in quotes, right? Because C is always the opposite way, right? So CD is your starting point. So let's go up to the very beginning just to check this out. What's my C and my D value for number 1? 0, 0. And where did my graph start? 0, 0. Right? What was my C and D for my second problem? 0, negative 1. And look where I started my graph. 0, negative 1. Right? Does my CD match up properly with where my graph started here? Yeah, Nick. My C is, I actually marked it wrong. My C should be fixed there right here. Did anybody catch it and not say anything? Because my C is actually -1. It's a -1. I put +1 because that's what it looked like, but it should be the opposite sign. That's got to be Siri, right? I don't think Android just activates. Well, actually, no, Android does activate that. So, anyway, so C should have been -1. Sorry about that. I didn't notice that I put +1 there. So notice -1, -1. That's where I started, right? -1, -1. And look at this one right here. My C should have been, again, -6. I'm not catching myself on that right there. -6, 0. Sorry about that. So I should start at -6, 0. And if you look at my graph, that's exactly where I started, -6, 0. Okay? Remember, C is always the opposite of what you see. Twice I wrote exactly what I saw, so that's incorrect. It's the opposite of what you see. Okay? So CD, and like I told you, the C is in quotes because it's supposed to tell you, be careful, make sure you write the opposite. I didn't do that. CD is where you're going to be starting your graph. Okay, so your first point, you don't even have to calculate it if you don't want to. You can just automatically put your C comma D value, -6, 0. Right? You don't have to calculate if you don't want to. Okay? I just wanted us to practice the calculations a bit. That way you can get used to it. In case you forget about, I can just use this point, right? So, all right, let me give you guys your homework, and that'll be it for chapter 6.